Hello again. Thanks for watching this video and studying your math with me. This video deals with section R2 from your book. You should read the section and stop and start this video to ensure you're learning what you need to learn. We'll be talking about sets of numbers. Of particular interest is the rational numbers, which are ratios of integers. And certainly the integers are also a ratio of integers because 2, for example, is 2 over 1. The rational numbers can also be represented as terminating decimal expansions or repeating decimal expansions. There are real numbers such as pi that do not have terminating or repeating decimal expansions, and so those are called irrational numbers. Together, the rational numbers and the irrational numbers both live on the real number line. Here's a Venn diagram illustrating the relative inclusions of these numbers. Note that the rational numbers and the irrational numbers are in fact disjoint sets. Here's a first classroom example. You're given a set of numbers here, and you're to list the elements from that set that belong to each of the following sets. Feel free to pause the video and we'll see how you did. Here are the answers that I got. Ask questions if you have questions about any of these. We're also going to be talking about exponents. If n is a positive integer and a is any real number, you can have a to the n, which represents n factors of a multiplied together. A is called the base and n is called the exponent. Here's some examples evaluating exponential expressions. You're to evaluate each expression and identify the base and the exponent. Let's see how you do. Here is, in this one in particular, the exponent is 4, but the base is the whole of minus 3. Contrast that with this example where the base is 3, but the exponent is 4, not minus 3. Makes a difference. This is 81, this is negative 81. Here's a fill in the blanks about the order of operations, so please do this. I filled in the blanks. This example 3, we're to evaluate each expression and using the order of operations. Here are my answers. You can also use the order of operations when you have variables, and here we're inserting values for the variables. We're evaluating an expression for x equal negative 4, y is 3, and z is negative 6. Here are the answers. Another fill in the blank dealing with closure properties, commutative, associative properties, identity and inverse properties, distributive properties, multiplication properties of 0. So fill in the blanks and we'll see how you do. Here is how I filled in the blanks. Here we're to use the commutative and associative properties to simplify each expression with the following results. Here we are to use the distributive property to rewrite each expression and simplify if possible. Note that here the negative on the outside changed the SIGN, the sign of everything inside the parentheses. Note here also that we were really using the distributive property in a backwards format where we're factoring out 11 from the expression. We will do factoring soon. The real number line possesses an order, and these questions deal with filling in the blanks about the ordering on the real number line. This is how I filled out these. The absolute value of a positive number is that number, while the absolute value of a negative number is the negative or opposite or additive inverse of that number. Here we're to find the absolute values and evaluate each expression. Note that in both this example and this example, the absolute value is evaluated first, and then we multiply by the minus sign to get the correct answers. Sometimes the absolute value is used in formulas, and here we have a P sub D is equal to the pressure measured minus 120, which is the target blood pressure. And so we're supposed to find the P sub D for a patient who has a pressure of 146. And there's the answer that I got. We can fill in the blanks about absolute values. Here's how I filled in the answers. This last one, that the absolute value of A plus B is less than or equal to the absolute value of A plus the absolute value of B, is called the triangle inequality and is especially important in calculus. The next classroom example is evaluating expressions for m equal 13 and n equal minus 9. So you should substitute those values in and evaluate the expression. Here is what I got. The last classroom example deals with distance of points on the number lines. It's filling in the blanks in completing classroom example 10. What I got for that one. In closing, remember time is precious. Each day must count. Do the math. It will make you strong. I will see you in class.